Welcome. My name is Nilesh. This video is part of the Festive Tech Calendar 2022. Before we go to the Festive Tech Calendar, I wish you a Merry Christmas and a very Happy New Year. If you don't know what is Festive Tech Calendar, it's an annual event where people from different communities they come together throughout the month of December and they share the latest technologies and the knowledge. We hope that you enjoy and learn throughout this month of December. If you don't know, head over to thefestivecalendar.com and learn more about what is the festive calendar. This year, Festive Calendar is doing something different. It is partnering with a charity called as Missing People, where it is raising funds for this charity. The target is to have £5,000 as the fundraiser, and currently we are at £982. So, if you are interested in helping this social cause, where this charity is doing great work in terms of finding missing people, please go ahead and contribute to this cause. Now, coming back to today's session, we are going to talk about getting started with Azure Container Apps. My name is Nilesh Kule and I work as a cloud solutions architect. I'm also a Microsoft Azure MVP since 2018 and I'm a co-organizer for Azure Singapore user group. Since I'm based in Singapore, I'm participating in these community activities where different things that we do as part of Azure Singapore user group. I'm also an international speaker and blogger. I blog at Hands On Architect and I also have a YouTube channel with the handle Nilesh-Gule. So if you're interested, please feel free to connect with me using any of these social media channels. Before we get started with Azure Container Apps, let's try to understand what are the different options for running containers on Microsoft Azure. We are talking about the native options. There are others like Red Hat OpenShift and Spring Cloud, which we are not going to focus during this discussion. So the native options in Azure to get started with containers include Azure Container Instances, which is on the extreme left here. This is useful when we want to run a simple one-off container. If we just want to try, let's say we build a container image using Docker or any other container platform, and we want to run that image, we can use the ACI or serverless option for Azure Container Instances. The next option is to run the websites and web applications or even the public APIs using web apps for containers. This is a platform as a service offering or PaaS offering. Third option is to use the Azure Kubernetes Service or AKS. Kubernetes being the most popular container orchestration platform. This is a managed offering from Microsoft and this is also one of the most popular service, most growing service in terms of its usage, I would say. This is a full-blown container orchestration platform where we have control over various things including like networking, security and other aspects which we want to control to the fine-grained options. When we want to get started with containerized applications, if we want to go with, let's say, Azure Kubernetes Service, it can be quite consuming for new developers. There are a lot of things which a developer needs to know before they can become proficient and they can have a very good operational version of the AKS cluster. So somewhere between a full-blown container orchestration and a PaaS offering lies the new offering from Microsoft, which is the Azure Container Apps. And this is targeted for building microservices kind of applications which are built using microservices architecture, and also the one where serverless is more in focus, where we want to build event-driven applications and those where we want to focus on having the serverless capabilities. So let's deep dive into the Azure Container Apps and see what does it has to offer for us as developers and as application engineers. Some of the main features which are related to Azure Container Apps includes the serverless containers for microservices. This is built with microservices architecture in mind and it supports all the capabilities which are required for building microservices and deploying them and having them run as serverless. This is also built using modern applications and open source projects and tools like Dapper. There is the Envoy proxy, which is used for service discovery and other things. and it is also using or supporting KEDA, which is Kubernetes-based event-driven autoscaling. The main idea here is we focus on developing applications and not so much on infrastructure. If you look at the other offerings, they have a bit of infrastructure component, and the developers, apart from focusing on building applications, it also adds a cognitive load on them to know about those things. So in terms of the developer productivity, Azure Container Apps tries to reduce that cognitive load on developers and makes it easy for application developers to build applications, to deploy applications, and to monitor those applications. It also provides a seamless port to Kubernetes. So let's say in future, the application team or the organization decides that the services which are offered as part of Azure Container Apps are not currently suited to their needs, and they want to migrate the application to Kubernetes. It is quite easy to port these applications which are built as part of Azure Container Apps to Kubernetes very easily. In terms of accelerating the developer productivity, it offers various things like it can be used to build microservices, APIs, event-driven processing, background processing jobs. It also supports polyglot programming model where we can use different kinds of programming languages. One of the things which microservices is popular for is we can have within the same application different components which are built using different programming languages based on the kind of workload. So let's say there is a front end which requires more of JavaScript based application programming. So we can use things like React or Angular. When it comes to the backend processing, we might use Go as a programming language. When it comes to the backing services, or let's say PubSub, we can use things like RabbitMQ, Redis, or Kafka. When it comes to databases, we could use different types of databases, which includes relational databases, NoSQL databases, graph databases. So based on the type, what is most suited for that workload, within the same application, we can build different components using different combinations of these programming languages as well as the backing services. And obviously the distributed applications. Being microservices, it allows us to distribute this across different parts of the system, and we can build highly scalable distributed applications. This can also be used to streamline other application lifecycle related events. Like when we build microservices, we have to handle things like the version upgrades, the traffic shifting, where when we use advanced deployment methods like blue-green deployment or canary deployment, where we want to do, let's say, other types of releases, we can use these concepts, something like service discovery, and even in terms of monitoring. All this comes packaged or as part out of the box with the Azure Container Apps. And from a CI/CD point of view, continuous integration, continuous delivery, or continuous deployment, it also supports setting up the pipelines using GitHub Actions. There is also native integration with something called as Dapr. So Dapr, if you don't know, head over to dapr.io to know more about the project, but this slide talks about what are the key features of Dapr. Dapr is a distributed application runtime which has support for multiple programming languages. Most of the modern day programming languages like Go, Node.js, Python, .NET, Java, C#, Rust, example, all these are supported in terms of the programming languages which can be used to build applications using Dapr. It can be used for HTTP APIs or gRPC. Wherever we can expose our code or our services as HTTP or using gRPC protocol, we can use Dapr for that. In terms of the cross-cutting concerns that Dapr supports, it has service-to-service invocation. It supports state management using traditional RDBMS as well as popular NoSQL databases or object databases. It has support for the publisher and subscriber models, PubSub models for messaging. When it comes to the serverless, the resource binding, it has support for things like block storage or blob storage and various other cloud services. Not just the public cloud services, but also third-party offerings. So in a short while, we will see what are the different components or supported services which falls under each of these categories. And it has support for things like observability, secrets, and we can extend Dapper. If there is something which is not supported by Dapper built in, we can extend it and we can provide that extension and that service by means of its extensible nature. In terms of hosting, this can be hosted in public cloud, private cloud, hybrid cloud scenarios, and covers all the major public cloud services as well as things like Alibaba Cloud on-premise. So basically, it covers the complete deployment cycle. It can be on-premise, it can be on cloud, it can be in a hybrid scenario as well. So to demonstrate all these things that we talked about so far, I'm going to use a small application called as TechTalks. This application is going to be deployed on Microsoft Azure. We have two major components here, TechTalks Producer and TechTalks Consumer. Think of TechTalks application as an application which is going to manage the technical events. And the producer is going to produce a series of events and consumer is going to consume those events. In order to consume these events or to decouple this producer and the consumer, we are going to use RabbitMQ, which is provisioned in Azure itself. And then we use Dapper to connect the producer and consumer. So let's see how we use these things. Before we head into the specifics, let me also quickly highlight what are the Dapper components that I mentioned earlier. So there are more than 100 components which are supported by Dapper at this point in time. When it comes to state stores or kind of storing the state for application, it supports AWS DynamoDB, it supports Azure Cosmos DB, Firebase, Redis, and Cassandra. When it comes to the messaging platforms like PubSub brokers, it supports AWS SQS, Azure Service Bus, that is support for GCP PubSub, Redis, and RabbitMQ. In terms of bindings and triggers, it supports S3 for AWS, Azure Blob Storage, GCP Storage, Twilio, and Kafka. In terms of the secret stores, there is support for AWS Secret Manager, Azure Key Vault, the GCP Secret Manager, HashiCorp Vault, and Kubernetes Secrets. In terms of observability, there is support for Prometheus, App Insights from Azure, Zipkin, and Jaeger. In terms of the configuration management, it supports Redis, and for distributed logging, it supports Redis again. So we can see that under the different components, there is more than one support for different types of services and cloud providers. Now let's switch over to the demo and see how we can use this. So I'm going to use this as part of this TechTalks demo, and let's get started. Let's first go and see what do we have for deployment. So as I said, I'm going to use the RabbitMQ, and all this code that I'm using is available in this repository called as TechTalks Azure Container Apps Demo. In order to save time, I've gone ahead and deployed some of the component, especially the RabbitMQ, because it takes certain amount of time to provision this RabbitMQ cluster on Azure. So you can go through the different steps. This README file will walk you through each and every step that is required to configure each and every component for this project. It also tells us how to build the container images from the source code. So I assume that you know how to build container images. If you don't know, you can refer to this page in terms of how to build the container images. So I've gone ahead and I have already created a RabbitMQ cluster here. And we can see that we have a queue named as RabbitMQ Consumer Tech Talk, and currently it doesn't have any messages to process. So to start with, I'm going to deploy the application, and I have a script here which goes ahead and deploys the different services which are required, or the producer and consumer which I'm going to use. So the script is named as Festive Calendar December 2022 demo. Let me go and run this script or trigger the script, and then let me walk you through what the script is doing. So we take different parameters for this script in terms of what is the subscription that we want to use. This is the Microsoft Azure subscription that I'm using. What is the resource group which we want to create? All the resources will be tagged to this resource group or created under this resource group, which is named as Azure Container Apps RG. The resource group location for this is East Asia, and I'll be using an environment name as ACI dev environment. So let's walk through the different steps in this script. We first go and set the Azure subscription. The script is idempotent, which means that we can run this multiple times and it will create exactly the type of resources which are required. So it first checks if the resource group exists. If the resource group doesn't exist, it will go ahead and create the resource group in the location that we specify. Then we create something called as the container app environment. Now think of the container app environment as the isolation boundary, or the way in which Azure Container Apps clubs together or combines together different resources for a particular container app. We can relate this to a physical environment, like if we have a dev environment, we have a UAT environment, we have a production environment, pre-production environment, or let's say system integration environment, SIT environment. So this environment is similar to that. It's a logical representation of your environment. Once we have the environment created, we go ahead and create a Dapper component. And the type of component that we are going to create is a PubSub component. So here we create a Dapper component by the name RabbitMQ PubSub, and we give it a YAML configuration that is required for configuring our RabbitMQ. So let me quickly walk you through that RabbitMQ configuration as well. So this is the configuration that we use for Dapper component to configure the RabbitMQ PubSub. The type of component is PubSub, and within PubSub specifically, you want to configure a RabbitMQ type of PubSub component. We specify the metadata saying the host which we want to connect to, what is the user, what is the protocol. We are going to use AMQP protocol to connect to RabbitMQ, and then it contains the IP and the port where this whole connection string would be used to connect to the RabbitMQ. And then we specify other metadata in terms of whether the queue is durable, what we want to do when the message is acknowledged. Do we want to auto acknowledge, or we want to manually acknowledge the message? We also specify the prefetch count, which is 50. This is the number of messages that would be picked for processing in one bunch of group or in a group. And then there are other similar properties. Once we have configured that, once the RabbitMQ component is available as a Dapper component, we go ahead and create a container app for our producer. Again, we use different parameters which is common to the script, like the environment, the resource group name. We name our container app as TechTalks producer here, and we specify what is the container image which should be used. So I'm using Azure Container instances, or ACR, Azure Container Repository here, or container registry, to point to the container image. So I have an image named as TechTalks producer, and it has a tag called as Azure Container App. So I'm going to use this version of the image with this tag, and I'm also specifying which is the registry server. So the server is NGACR Container Registry under the Azure CR, or Azure Container Registry. We also specify the port which needs to be exposed, or which needs to be connected, and the ingress. Ingress is a way we expose the application outside of the Azure. So we are specifying ingress as external for our producer, which means that we will be able to connect to the producer from outside of Microsoft Azure. And we specify other things like enable Dapper. By means of enabling Dapper, whatever components we create as part of Dapper in this particular environment, all those will be available to this container app. And then we specify other metadata, like what should be the ID, what should be the port, the number of replicas, minimum and maximum. So we are starting with minimum 1 replica, and Since it's a serverless offering, we can specify what is the maximum replicas that this has to go to. Azure Container Apps has its own logic based on which it will decide whether to scale up or scale down these many number of replicas. So I'm specifying the range from 1 to 3 here. Similarly, we create the other container app for the consumer. The process is exactly same. The only difference here is the name of the image which we are referring. Instead of TechTalks producer, we are going to use the TechTalks consumer here, and the ingress type here is specified as internal. Since it's a consumer, I do not want at this point in time to expose it to the outside world. I just want to use it internally within my environment. So I'm specifying the ingress as internal. With that, if the script has run correctly, we should have all our services created. So let's quickly scan through the output that we got. So we can see here that it has created the resource group. It says that the resource group already exists, and it didn't find the ACI dev environment. It was not available in my resource group, so it has gone ahead, created the Azure Container Instances or Azure Container Apps environment here, and then within that environment, it is going to create, or it has created the Dapper environment or Dapper component. Sorry. Once the Dapper component is created, the PubSub component, it has gone ahead and created the container app for producer, and same way it has gone ahead and created the container app for the consumer. So we have all the components that are required for running our application. We can verify this by going to the Azure portal, and in our resource group, which is named as Azure Container App RG, if we refresh, we should be able to find all the resources which are linked or which are part of this resource group. So we can see that ACI dev environment is part of this resource group. There is RabbitMQ and various other resources related to the RabbitMQ. And we have the TechTalks consumer and TechTalks producer applications here. Let's head over to the TechTalks producer and we get the application URL. Let me copy this, and we can see that it is named as TechTalks producer .bluepebble .ac and East Asia Azure Container Apps.io. We will need this in order to generate the workload. So let me switch back to the Visual Studio Code, and I have an extension which is used for running HTTP request. In here, I'm going to replace the URL from the previous URL, and we are going to point to that particular producer instance. Now let me go ahead and send request. Let's say instead of 15,000, we are going to generate 10,000 number of messages. Let me send this request, and we will get a response from this demo.http script. So we got 200 OK as the response, which means that the number of messages were generated, and we can see here that there is a spike here, and we also see the number of messages generated, and we can see untracked number of messages as 50, and the consumers is one consumer is running. So this one consumer is going to process those 10,000 messages that we generated, and because of that configuration where in the RabbitMQ config in our Dapper component we set the prefetch count as 50. Once the 50 messages are processed, in the next batch it is going to again fetch 50 messages. And the way we are using this in the producer and consumer also is the way we link it is, let's look at the producer first. So I have this code which is used to produce these messages. So if we look at this code, we can see that it uses the PubSub name. This is the name of the component, RabbitMQ PubSub, that we specified in our Dapper configuration, PubSub RabbitMQ. That is exactly the same name, or This is the name which we got from the script. Sorry. So let me go back to the script, and if we go back, that's the component name. So you can see here that we were using RabbitMQ PubSub as the name of our Dapper component. So that is the component name we use, and then the topic name is Tech Talks. With only that configuration, we can create a client for Dapper, and we can say publish event async, name of the PubSub, topic, and then the actual workload or the actual contents of the topic. That will publish those 10,000 messages. On the consumer side, when we go, it's again an API which is using the same RabbitMQ PubSub topic and the Tech Talks as the topic name to consume. And all that we do here is we simulate a process which is taking, let's say, 1/4 of a second, and we log the Tech Talks detail. That is what the consumer is doing. So you can see that we have no code which says that this is connecting to a RabbitMQ. All that is abstracted by Dapper for us, and just by giving the name of the PubSub component and the name of the topic that we want to connect to, both the producer and consumer are able to connect to Dapper, and they are able to communicate with one another. So this is still ongoing. Now the problem with this is it is only one consumer, and it is going to take a lot of time if we wait for all the messages to be consumed. This is where I want to introduce another topic which is called as KEDA. Now, KEDA is an open source project which is named as Kubernetes-based event-driven autoscaling. It has various components called as autoscalers. Out of the box, it supports more than 50 different autoscalers, and it can be used in a way where instead of relying on traditional metrics like the RAM usage or the CPU usage, we can use external sources of event like Kafka, we can use RabbitMQ, we can use MongoDB, we can use traditional RDBMS like Postgres, MySQL. It can be used to connect to any of these different sources from where it can scale. And then based on a type of parameter, like in case of messaging, in case of RabbitMQ, based on the number of messages which are there pending for processing, we can go and scale the number of consumers in this case. So I'm going to introduce KEDA in our whole application. The KEDA will sit in between our RabbitMQ cluster or RabbitMQ queue and the Tech Talks consumer, which is consuming those messages and processing those messages. The way we are going to do is, as long as there are certain number of messages to be processed in the RabbitMQ, we want to scale the consumer. So for this purpose, again, I have a small script to configure this. Let's go and look at that script, what it is doing. It's going to again refer to the same set of variables. What is the resource group name, what's the location, and the environment. Then we go and create a secret in order to connect to the RabbitMQ. So if the secret doesn't exist, it will go and create a secret with the name as Tech Talks consumer. And then our the container app, which is named as the Tech Talks consumer, which we created earlier, we are going to update some of the metadata related to that. Initially, we created that with one replica. Now we are going to update it to say the minimum number of replicas it should have is 1, and maximum number of replicas it should have is 25. We are also going to define a scale rule, which is named as RabbitMQ KEDA autoscale. The type of the rule is RabbitMQ. So if we go back to our presentation again, we see there are different types of these autoscalers. So that is why we are specifying this rule type as RabbitMQ. And then we specify some metadata like what is the authorization which is used, or that secret which we created earlier, and then what is the metadata for that particular scale rule. So we are saying the name of our queue is RabbitMQ consumer Tech Talks, which is exactly the same as the queue that we are using currently, RabbitMQ consumer Tech Talks. And then we are going to use the mode or the parameter for that is the queue length. As long as there are 50 messages, we want to scale within this 1 and 25 range for the replicas. So let's go and apply this scale rule. Let's clear all this. Let's list down all the files that we have in this. So we have this autoscale consumer .ps as the PowerShell script. Let's apply that autoscale consumer to our deployment and see what happens. So you can see here that the container tech talks does not have a secret currently assigned named as RabbitMQ host. This is the idempotent script that I was talking about. So we can run this script multiple times, and if the RabbitMQ host secret exists, it will not do anything. But if it doesn't exist, it will go and create that secret for us. So as part of this script, we will have that RabbitMQ host secret created, and the auto scaling rule applied, or the scaling rule applied to our consumer. Once we have that, what we should be seeing here is these number of consumers, which are currently just 1, it will start to scale progressively. Again, since we specify the range as 1 to 25, it doesn't mean that the Azure Container Apps would scale directly from 1 to 25. It uses a progressive scaling approach where it will increase the number of consumers from 1 to 2. It will see if 2 is enough to consume the messages. So you can see here, right now we have 2 consumers. If 2 consumers are not enough, then it will scale to 4, then to 8, and same way it will scale to the maximum level in a progressive manner. So you can see it went to 3, it went to 5, and we have 250 messages now. It will keep consuming those messages in the batch of 50, and also based on the number of messages which are pending in the queue, it will scale the number of consumers. Same thing applies to scaling down. If there are not enough number of messages, it will start scaling down from the number of consumers. So we can see that each of these consumers, they have 50 messages consumed, or the prefetch count is 50. We can also verify this by going into our resource group and heading over to our TechTalks consumer. How do we know that those messages are actually getting consumed? So we can hook into the log stream for that consumer, and it will show us all the current replicas here. So you can see that it's showing 1 replica, and from that replica, it's logging that the message is being consumed, and it logs the message details like what is the TechTalk ID, what's the name, category, and the level of that message. And if we go back, we will find that for every second there are 4 messages which are consumed because of that slight delay that we have. Now if we refresh this in a while, we should be able to see all those replicas which are created as consumers. So that shows that whatever we are seeing in the RabbitMQ management console here with 13 consumers currently running, the same information is available in the Azure portal as well. So let's go back and continue from where we left in the presentation. So what we saw is we enhanced our consumer by incorporating KEDA as the auto scaling mechanism, which looks at the number of pending messages, and based on that, it will scale our consumer within a range. So a quick summary of what we did so far in this session. We created the Azure Container Apps environment, which allows us to isolate, or which allows us to create a boundary where we can deploy 1 or more container apps within that environment. We also defined the max and min replicas for our producer in order to scale automatically based on the default parameters which are used by Azure Container Apps. We also used Dapper for connecting our producer and consumer, which provides us that abstraction. And tomorrow, if we replace, let's say, RabbitMQ with Kafka, our code in the application side doesn't have to change. We only have to update our Dapper configuration, the PubSub component configuration, to point to the Kafka instance instead of RabbitMQ, and we need to provide the metadata for Kafka. We also used KEDA for auto scaling based on the external event, in this case the RabbitMQ, which contained thousands of messages in the queue, to scale based on the number of messages. So that was just one example. What are the other types of applications where we can use Azure Container Apps? It is targeted for building microservices, and that was one thing which we saw in this example. We used KEDA as the auto scale criteria. We can also build event-driven processing types, where we use queue as a mechanism for decoupling the producers, consumers of the messages, and then exactly the same criteria which we used here. The number of messages can be used as auto scaling criteria in case of event-driven processing applications, where one of the POP-sub mechanism or one of the queuing mechanism is used to communicate between different components of the microservices, or different components of the application which are built as different microservices. We can also use Azure Container Apps to build traditional web applications. It has support for having things like custom domains, the TLS certificates, the authentication is integrated with this. And for this kind of things, we can use the HTTP request, the number of concurrent requests, as the criteria for scaling. We can build public API endpoints where we need to do things like blue-green deployment or canary releases, dark launches, where we want to split traffic between different versions of the application. So there is this support provided for splitting the traffic, and it can also be used for building background processing. So in terms of references, I would provide these different references related to the Azure Container Apps, Dapr and KEDA. There is one interesting session which was done by Donovan Brown at the Ignite event this year, where he used Dapr and he showed how to do polyglot programming, where within Visual Studio Code as the code editor, we can connect and we can debug different types of codes, different programming languages like Java, Go, .NET, Python, for example, using the same ID. We don't have to switch our code editor to different things, and all this was connected using Dapr. So if you found this session useful, I highly recommend that go back and watch this Donovan Brown session at the Ignite to have better understanding of how Dapr can really improve the developer experience when we are building polyglot programming and when we are building microservices using polyglot processing. The source code for whatever I showed during this demo is available online. It's there on GitHub, and the slides for this demo is also available on SlideShare as well as SpeakerDeck. I hope you found this useful. In case you would like to connect with me on any of the social media platform, the combination of my first name and last name is quite unique. You will be able to find me with Nilesh Gule as the handle in almost every case. Thank you for watching this video, and please go ahead and watch the other interesting content which is part of the festive tech calendar. Once again, wish you a very happy new year. Thank you.